Crizarel here. In the previous video, I said that there was no way to eliminate the allocations from this method call right here, from statModifiers.removeAll. Turns out, I was completely wrong. A viewer promptly pointed out a way to do that in the comments. Shout out to internal read-only void. And in hindsight, it's honestly kind of obvious. So in this video, we're gonna implement that. I actually ended up deciding for a slightly simpler implementation than what he suggested in his comment. So today we're gonna implement that and eliminate allocations completely. So what we need to do is, similarly to how we stored the comparison up here, this time we are going to store a predicate. And we are also going to store an object. And once again, I am using nullable reference notation here because I have that enabled in my project. But if you don't have it enabled in yours, you don't have to add the question mark here. And let's call this object source to remove. So for the predicate, we need to assign it in the constructor. And the predicate is going to be a function that receives a modifier and then compares the source of that modifier to this class variable that we just declared. And now, in the remove modifiers from source, instead of generating a new lambda expression every call, we use the one we just stored, and we also store the source that we received as a parameter to the source to remove variable that we just declared and that we use in the predicate. We also should set this variable to null when we are done, just to make sure that we don't prevent this source object from being reclaimed by the garbage collector, because in case you don't know, the garbage collector works by figuring out how many things are referencing a particular object, and if an object no longer has any references to it, then it will be marked for garbage collection. So if we end up being the last class to have a reference to this source object, then we could be preventing it from being garbage collected, and we don't want that. Let's go back into Unity and check the allocations in the profiler. And as we can see now, remove from source now has 0 allocations per frame. You may be wondering why this works, and that's because of a concept called closures. So let's turn this back into the original predicate, just so we can compare what the difference is between the new one and the original one. So if we hover over this lambda expression declaration, in the tooltip you can see it says variables captured source. That means this source variable here, that is a function parameter, is being captured by this lambda expression, meaning it has to generate a new lambda expression that refers to this variable every call. In contrast to that, if we come up here to the new predicate that we declared, and we do the same thing, instead it says that it's capturing the variable this. That means this entire CharacterStat class is being captured instead of a local variable. So it's the equivalent of doing this here, this dot source to remove, right? So this new lambda belongs to the class, and it captures the class itself, which will be the same object for as long as the class exists. Whereas before, the lambda belonged to one specific method call, and it captured its local parameter, which is a different variable every call. Now, I am pretty happy with the implementation that we have, because one of the goals of the CharacterStat system is implementation simplicity, and it doesn't get any simpler than this. However, If you want to generalize things a bit, you can make some changes, like converting the lambda into a class function, like this, or wrapping the whole thing in a separate class, like the commenter suggested. Like this. But like I said, I'm happy with the original implementation, so I'm going to stick with that. Thank you for watching, and I'll catch you again in the next one.